Good morning, everybody. Can you hear me?
Yeah.
Okay, good. Good. 'Cause I never know about this machine. Oh, all right. That might be everybody. We'll see here. I'll take roll. God dang it. All right. Give me a holler if you're here. Cole,
Here.
Haley,
Here.
Heidi,
Here.
Oregon,
Here.
Ella,
Here.
Noah,
Here.
Lynn,
Here.
Andrew,
Here.
Zach,
Here.
Christian,
Here.
Nick,
Here.
Olivia,
Here.
Noah,
Here.
okay, Dominic,
Here.
Ari,
Here.
Jack,
Here.
Bryce,
Here.
Jake,
Here.
Darcy, Darcy, where are you? All right, should probably come in late. Cora, you're here, right?
Yeah, I'm here.
Kaya?
Here.
All righty. So, like I was telling some friends last night, what used to take me 2 hours to correct takes me 2 days. So I have everybody's quizzes corrected in this class. I have 2 people yet to correct in the other class. I have your scores in there. I want to email you your results. So I believe that will happen because I have lunch at home and I have a scheduled half-hour lunch after here. Oops, I figured Darcy would show up. Hi, Darcy. So I'm just taking attendance here. So what I'm going to do is I'm going to go through the quiz. It will be recorded. At lunch, I'll send you your results. So if you did it on paper, I'll scan it, send it to you. If you did it online, I'm assuming you have a copy of that, and I will send you my marks on it like I did last time. If you can watch the video of my explanation, and at any time, if you have any questions, you can send me a text or an email. I'll take a look at it. Also, this morning, we have now what's called, anyway, I don't know, it starts at 8:30. And it's like I have office hours. So if you have a question or concern, or I need to explain something better, or you can check in with me. So you know how you got that invite? It's kind of that time it's kind of a study time that if you need, it's not required that you do that, but it's a more access time for me. Is that making sense with everybody? And I think that'll work out really good, especially next Wednesday, because next Wednesday we have a test scheduled at this time. And I will write the test so it is that if you have, what do we have, like 55 minutes? It can be completed in 55 minutes by the general group. Does that kind of make sense? But that's actually not a bad time for anybody that's got questions, specific questions of what they think might be on the test or some issues. But if you have any issues, like you want to say, hey, I don't think you scored this quiz, the one I'm going to go through, or the one we have next Monday, which I hope I'll have done by Tuesday. I might have to put an all-nighter in to get that done. You can ask at those times. Does that make sense to everybody? Okay. All right, so I'm going to share the screen. I'm going to go through the quiz. I'm going to tell you what I'm looking for, and I'll talk about how I scored it. Okay? And anytime, if you have any questions about some clarifications, you can just interrupt me and say, hey, what about this? Okay, everybody got that? All right, let's see if I can share this successfully. And so one thing, let's see if I can slide this a little bit. How can I move this? There we go. All right, you can see this, correct? Or maybe not. Can you guys see this?
Yeah, we can.
Yeah, we.
Okay. All right, so I have 3 parts to this piecewise graph. What I do is I put 2 into here. Now I know it can't equal 2, but when I get 2, -3, I put an open circle right there. And I'm going to draw what it looks like to the left of 2. Well, it's a line with a slope of 1. So if I plug in the next number that's to the left, or excuse me, the next whole number that's to the left, I'm going to get a -4. So right here's a -4. Here's this point. I can draw this. The next one is just a single point. It's the point 2, 3. And the next one is if I put in 2 here, -3 times 2 is a -6, plus 3 is a -3. I'm here. Now it has a slope of a -3, which means I'm going to go down 3, 1, 2, 3, and over 1. So there's my approximate. So that's the graph that I'm looking at. Okay, so this was worth 3 points. I had to look to see that this dot was in the right place, this line was in the right place, and this line was in the right place. So this next one's worth 1 point, so this was worth 3. This particular, the no calculator part, was worth 16 points. It says use the graph from problem 1 to take the limit, and then justify your limits. Justify using limits with your answer. So to get the whole 1 point, it was either 0 or 1. So if I take the limit as x approaches to, this is simply a whole. I'm approaching -3 as I approach from the left and the right. And I'm going to say that equals a -3. Why? And you can write it like the limit as x approaches 2 from the left of f of x equals the limit as x approaches 2 from the right of f of x. Now, so you had to have this complete thing. Some people just wrote it out in words. That's fine and dandy. I had people that did this. That's not acceptable. So I took off points for that. I had some people that did this. That's not acceptable. It's got to be written in this form. So I am kind of picky on that. Any questions about 1 or 2? All right. Number 3. It says sketch a graph of a function that satisfies the given values. So f of -2 equals 0 is defined. That's on the x-axis. F of 2 equals 0 is defined. That's on the x-axis. And it's a function. So it has to be a function, which means I can't have any lines crossing. It says as you approach 2 from the right and the left, you're going to get 0. So that means I do something like this. So it means it's continuous there. And then says here, the limit does not exist. Well, how is that possible? Well, I can go to here, and then what I'll do is I'll put an open circle, and I'll create a jump there. So that's what you had to receive for 4 points. Any questions on that? So this was worth 3, this was worth 1, this was worth 4. So we're up to 8 points on this page. Then we had this graph, 1, 2, 3, 4, 5, 6, 7, 8. So you see where the other 16 came from. F of -2. So if I look at a -2, there's no dot along here. In fact, there's an asymptote. So it does not exist. If you wrote undefined, I took off half of a point. You need to write that it does not exist. Equals the limit as x approaches a -2. Well, that does not exist, because it's going to negative infinity from this direction, it's going to positive infinity from the other direction. F of 0 exists, it's 4. But the limit does not exist because it's approaching a half, it looks like, because here's 0, 1, 2. It's approaching half from the left and 4 from the right. F of 2 does not exist because all I have is a hole there. The limit, though, does exist because it is a hole, and that limit is a half. F of 4 exists, and that is 2. The limit does not exist because I don't know what in the heck's happened here. It might be an asymptote, who knows? So those are the 4 answers that I was looking for. Any questions on the no calculator part? All right, next page. So what I did is I put these values in a calculator, and now I wasn't too picky on this because you will get slightly different answers depending upon if you have a Casio or a TI. A Casio tends to have a larger processor, so it gives you more of an accurate depiction. But I only went 3 decimal places because that's what you're required in AP Calc. So these are the values I came up with when I simplified this. I came up with a -0.734, a -0.088, and a -0.008. This is undefined, or it doesn't exist, it's not in there. And so it's 0.009 I got here, 0.092, and then 1.096. So these numbers, as I approach from the left and I approach to the right, they're getting smaller and smaller. So they are approaching 0. The next, it says, use the table below, okay? Using the table below, find the limit. So I got to have an answer here. So as I'm approaching 3 from the left, I'm headed to E, which is 2.718. Here I'm at 2.73, 2.72, 2.79. So I'm decreasing here, approaching E, which is 2.718. Over here, as I'm approaching 3 to the right, I'm just getting closer and closer to 2. So it does not exist. And so here was 1, 2, 3. Here's 1, here's 2, here's 3. E is somewhere right there. And so I had this. It's decreasing to that spot. Then right here is 2. And it's increasing to that spot. Here I'm at 3.1 and I'm at 1.9. I'm moving up as I'm going from right to left. So I had something like this. So I needed to see that on your graph that there was a hole here or a hole here, one of these places. Well, it says 3E, so there's no hole there. There'd have to be a hole at 2. And I had to see that gap. I had to see that you drew a jump. So this was worth 2 points. 1, 2, 3, 4 on this page. Any questions on that at all? Over here, well, the first thing you want to do substitution if you can. So I had a lot of people do this. 3 to the third plus 1 over 3 minus 4. Just substitute it in there. The biggest mistake is people took 3 to the third and got 9 and then got 10 here. Well, your answer is going to be a negative. This is 27 plus 1. It's going to be a negative 28. Here, what you had to do was multiply by the conjugate. Here I have x. I'm going to multiply this by the square root of x plus 9 plus 3. And that's going to give me x plus 9 minus 9 over x times the quantity x plus 9 plus 3. And so I have some simplification that's going on here. I have 9 minus 9. And then I have x, which is 0. X plus 0 is x. X divided by x is 1. So there's a 1 here. So this is going to give me now, this is limit is equivalent to the limit as x approaches 0 of 1 over the square root of x plus 9 plus 3. I can substitute 0 now into here because it doesn't give me division by 0. I get the square root of 9, which is 3, and 3 plus 3 is 6, so I get 1/6. I was pretty pleased as a class. Overall, you did really, really well on this page. Probably better than, I would say, almost all the other classes that I've taught in calculus. So you guys should give yourselves a pat on the back. So here I have a fraction, so I can get a common denominator. So I'm going to multiply this top by 4 and this bottom by 4. And I'm going to have 4 minus, then I'm going to multiply the top here by x plus 4 here and x plus 4 here. So I got parentheses x plus 4. And down here I have 4 times x plus 4 divided by x. Now, I got to distribute this minus sign, and this is where some people made a mistake. They would, rather than having 4 minus x minus 4, they had 4 minus x plus 4. You have to make sure that you distribute that. And then I multiply by the reciprocal right away, and I get 0. And this is a negative x. Some people lost some points because they didn't write a negative x here, so it's going to be a negative 1. And negative 1 times a negative 1 is a negative 1 over 4 times x plus 4. So now that's going to be equal to the limit as x goes to 0 of the negative 1 over 4 times x plus 4, which gives me, now I can substitute and I get negative 1/16. Okay, so this is, you're going to get, because you have two variables here, you have x and you have h. In this case, you're going to get some type of expression in terms of h. So again, I got to get a common denominator, and I'm going to multiply this fraction by x and the other fraction by x plus h. So I have 2x, again, minus 2 times x plus h over x times x plus h over h. So I'm going to distribute on top. I'm going to have 2x minus 2x minus 2h over x times x plus h times the reciprocal of h, which is 1 over h. I have 2x minus 2x. That's going to give me 0 minus, this is going to, 0 minus 2h is going to give me a negative 2h, so it's negative. This h and this h will simplify, and I'm left with a negative 2 over x times x plus h. So this is going to be equal to the limit as h, excuse me, I wrote x, as h approaches 0 of a negative 2 over x times x plus h. And that's going to give me, now I substitute 0 in for h only. X is not touched. So it's going to give me a negative 2 over x squared. Now, a couple of comments on how I scored this. Like up here, if you did multiply by the conjugate and you did some inaccurate algebra here, I took off 3/10 of a point. If you're again multiplied by this and you took a negative 3 times 3 and wrote a minus 6, I would take off 2/10 of a point because that's an arithmetic mistake, and that's just, you know, kind of glitchy. So that's the difference between 2/10 and 3/10. If you had no idea, I took off 1/10 of a point, but let's say you multiply by the conjugate here and you didn't multiply, you knew that you had to multiply by the conjugate, and that's as far as you can get. I took off 7/10 of a point, so I gave you 3/10 of a point. In other words, I just saw this and then didn't see any work, or saw work that was, I have no idea what you were doing. And like I said, there are very, very few of those. Number 7, again, do some algebra here. So I'm going to square this, and inside parentheses, I'm going to have x squared plus, well, it's x times delta x and delta x times x, which are the same, and I got 2 of them. So I write it that way. Again, these are 2 separate variables, plus delta x squared minus 2x squared. Now, I had some people that chose and divided by delta x. I did have some people that chose some voodoo math and said, when I square this, I get x squared plus delta x squared, and did not include the middle term, which is a voodooism. So this is, oops, I got to have parentheses here, not here. Sorry about that. So this is going to give me 2x squared plus 4x delta x plus 2 delta x squared minus 2x squared, once I get rid of the parentheses, divided by delta x. And these are going to be gone. I'm going to factor out a delta x. That's going to give me 4x plus 2 delta x. And I have a delta x down here. Those simplify. So now I'm going to replace this, and I'm going to take the limit of this of 4x plus 2 delta x. And this is what's going to be replaced with 0. And when I do that, I get 4x. Any questions on that? Last one, all I had to do was take a negative 2 and cube it. That gives me a negative 8. All I had to do here was take a negative 2, multiply it by 5, and that gives me a negative 10. So those were the two answers. So if you take a look at this, this was worth 1, 2, 3, 4, 5, 6, 7. That gave you a total of 11 points. And so you'll see that I took your total score and divided it by 27, 16 plus 11. And that's how I get that out of 10. Any questions about that at all? So we went through, let me get back to, stop sharing this, get back to this. So what I thought, rather than, so today is Wednesday, tomorrow's Thursday. Tomorrow's notes will be really, really quick. It's just one sheet. I'm going to finish up 1-4 and 1-5 notes tomorrow. I'm handing out today this continuity sheet. In fact, I'm going to give that to you right now. And then you guys can call it up. And some of you had it handed to you, so I do want to talk about that. So let me go to Schoology. Okay, give me 1 second here. Here, I bet you this is it. Yeah, that's it. All right. If you go to Schoology, you should see an assignment called Continuity Packet. And some people got it handed to them yesterday. And I'll share this with you. All right, so there's a number of problems on the AP exam in which you have to justify, and how you write your justification is pretty important. And so this is kind of what we talked about yesterday with how to write a good justification. It's dealing with the intermediate value theorem. And the big thing is anytime I start my justification, you will see that I say this particular function is closed, and I always say what interval it is closed on. And I always write that as a closed interval, and I'll show you what I mean by that. And then what you're trying to do is they will give you a y value, and you want to show that the y value is between two other y values. And if a y value is between two other y values, because it's continuous, there must be an x value that a lot of times I just call c, which is what it says here, which is between the interval in which the function is continuous on. All right. And so there was this particular example, and I can't remember if I did this in this class or not. Here's your function. Your function is negative e to the x times the cosine of x. It says showing without using your calculator that there exists at least one zero in this interval. So what does this zero mean? It means the function is a zero. So the function crosses the x-axis. So if you take a look, and I think it shows on a TI, let's see if I'm correct. If I go to a TI and I go to second calc, one of my choices is a zero. Well, what is that zero? That zero is where the function crosses the x-axis. So a 0 is saying an x-intercept. It means my y value is 0, not my x. Because it doesn't make any sense if I'm in an interval between 0 and pi, or closed interval between 0 and pi, I'm looking for the 0. I mean, I could, and I think I'm going to show you in a later problem when I flip this over, that a 0 simply means y is 0. So what they did is they plugged 0 into this function and got a -1 here times 1 and got a -1. So you know that f of 0 is less than 0. F of 0 is negative. It's below the x-axis. If I would graph that, and I have no idea what this graph looks like, but I know over here on the left endpoint for the interval, I'm at 0, -1. I'm right here. I'm below the x-axis. There's 0, -1. And if I put pi into here, so here's 1, here's 2, here's 3. So pi somewhere here. If I put pi in there, well, I'm going to get 2.718 raised to the 3.1 power. I know that's bigger than 8. So let's say here's 8. So let's say it's up here. And I don't care exactly where that endpoint is. It's simply that it crosses somewhere between here, between 0 and 3, or maybe it dips down here. I don't know exactly where it crosses, but it has to cross the x-axis somewhere to get up to here. So what I'm saying, look at my justification. F is continuous. Where is it continuous? On this interval that you stated. And then I say, all right, I plug 0 in, that's this left endpoint, and I get a y value, -1. And I show that. And if I plug in pi, I get e to the pi, which means there has to be a 0, which in here is called k in the definition. It's some y value. The y value I'm looking for is 0 in this one, some k that's between these two y values. So there has to be a c within this interval between 0 and pi that gives me that when I plug it in the function, this is my x-intercept. This gives me 0. And then last two things I put in is by IVT. So there are 4 parts I look for. I look for this part right here. I look for this part right here. Well, actually, I should include this. I look for this part. There exists a C in that interval where this is true. So 1, 2, 3, and then 4 by IVT. So let's flip it over. And I say, please follow this format, please follow this format, please follow this format. So if you flip to the other side, here's an AP question. It's a multiple choice. And it says, let f be a continuous function. So there aren't any breaks. Selected values of f are given in the table below. So these are 1, 2, 3, 4, 5 points. There's an infinite number of points between 1 and 8. They only gave you 5. They said you have a closed interval from 1 to 8. What's the least number of solutions does this equation f of x equals 1/2 have on this? Well, how would I approach this? Well, some people, what I do is I'm a visual person. So what I do is I create a graph. And I mark it 1, 2, 3, 4, 5, 6, 7, 8. And I mark those points. So I'm at 1, -2. I'm at 2, 3. I'm at 3, 1. I don't have a 4. I'm at 5, -5. There's -2, -3, -1, -2, -3, -4, -5. 1, 2, 3, 4, 5. and I'm at 8.7. So I'm up here somewhere. And I know it's continuous. So I draw this, and it doesn't have to look like mine, but that's what I'm having. So that's what my graph looks like. Somebody else could come up with something else. And it says, all right, what's the least number of solutions that equals 1/2? So where are the y's equal to 1/2? Well, here's 0, here's 1, here's 1/2. So if I draw a line here, how many times does that graph cross 1/2? 3 times. That's my answer. You can also see I started at -2, I went to 3, so I must have crossed 1/2. I didn't cross 1/2 here, did I? Going from 3 to 1, but I did cross 1/2 going from 1 to -5, and then again from -5 to 7. So you don't have to draw a graph. Some people are more analytical and they see that. Some people like to draw the graph. All right, the last problem that I'm going to talk about, well, maybe not. Maybe I'll complete this and then I'll show you what you need to do. It says, now let's work on justifying a free response question. Notice we have a velocity function. So I have time in seconds, and then I have velocity, and it gives me feet per second. Notice some of these are negative. Here's a 0, and here's a positive. Gus, how are you doing?
I'm doing great.
So are you like busy doing lawn care yet?
A little bit.
So you're going wondering why I'm even asking you and what does this have for calculus, right? It's going to make sense in a second, okay?
All right.
So do you ride a lawnmower or do you push it?
I ride it.
Okay. And is it one of those that are 0 turning radius?
Yep,
Okay. Do you ever go backwards?
I do.
Okay. Do you ever go the same speed forward and the same speed backward?
Yep.
Yeah. Okay, super. So explain to me how I can have negative velocity and over here I have positive velocity.
Because you're going forward in one and you're going backwards in the other.
So velocity not only tells me my speed, it tells me the direction I'm going. Would you agree with that?
Yeah.
So these, if this was a positive 10, it's not. If it was a positive 10, but let's just say it was, it just means these would be going the same speed, just in opposite directions, correct?
Right.
All right. So speed is really the absolute value of velocity. Would you agree with that, Gus?
Yep.
Okay. That's a really important idea in calculus. I got one more question for you, Gus.
All
What
right.
does this mean?
What?
Do you see here at 50 seconds, it's 0. What's it mean?
Just you're standing still?
Yeah, for maybe a brief amount of time, right? You don't know. You don't know
Right.
what happened at 51, do you?
Right.
But the person, like, I don't know how it works. Do you have to step on the brake to go into reverse, or can you just slam it into reverse and it heads the other way?
No, you can just slam it.
Oh, you can. Okay, does it
Yep.
pause briefly and then just
Yep.
head the other way?
Yeah, briefly, I would say.
Very briefly. Can you feel it in your body?
Yep.
Okay. So that could have happened at 50 seconds.
Right.
That all of a sudden you went from reverse to forward, correct?
Right.
So this is something you experience on a regular basis that is actually mathematical.
I would say.
All right. God, it's like I should pay you money, Gus.
I think you should.
It's going to become a time, Gus, where I'm not going to want to mow the lawn. I might give you a holler.
But I got a business card waiting for you.
Okay, bring it. All right. I'll have to wait till next week, though, right?
Yeah.
Okay. So it says here, a towed car travels on a straight path. Oh, this isn't a mowing thing, it's a car. During the time interval, somewhere between 0 and 60 seconds. Now notice time is the input value, velocity is the output value. Some students get these confused. So make sure you know, hey, these are my X's, these are my Y's, if you do decide to plot them. The toy car's velocity, v, measured in feet per second, is a continuous function. For the open interval, 0 to 60 seconds, there must be a time t where t equals a -2. So, I think it's a question. So it's yes, it says for the interval 0 to 60, must there be a time t when v of t equals a -2? William, would you say yes or no to that? Or William, are you even in this class? Maybe I got you in the wrong class. I got you in the wrong class. Olivia, would you say yes or no to that?
I think yes.
I would agree with you, yes. Okay. Why do you believe that to be true?
Well, because there's a 0, and I think that's when you have to stop. You hit -2 when you're going to stop.
On your way to stop it.
Yeah.
I would agree with you 100%. Okay. Now, the AP people are going to want you to write something out. Okay. So I'm going to write yes, and then I'm going to put a comma here, and this is going to be our justification. What do you think should be the first part of our justification? Want me to give you a hint?
Yes, please.
V of t is.
Um,
And it tells you in the directions, or it tells you in the information.
would you say v of t is -2 at something?
I mean, we don't know where it is a -2. We're guessing it's between 35 and 50 seconds, right?
Right.
Okay, but it doesn't ask us between 35 and 50. It's asking us between 0 and 60, correct?
Mm-hmm.
So we're going to use those, but this function has to be something. You see how can you see my graph up here, how beautiful it is?
Yeah.
For a person that failed coloring in kindergarten, which I'll tell that story somewhere down the road, that's a beautiful function. But notice what I'm doing with my pen. I'm not lifting it off my paper, correct?
Yeah.
That means that function is what?
Continuous.
Right. V of t is continuous because it says it up here, but I reiterate it again. I say it again, okay?
Okay.
And now what I'm going to do is, okay, what is my value? This is 0 seconds, correct? So I'm going to say, and v of 0 equals, oh, excuse me, I do this all the time. I screwed up. I'm going to cross this out. It's continuous in what interval? That's going to be the first part. I'm crossing this out. It's continuous in what interval? What interval am I given?
The 0 to 60.
Right, it's a closed.
Right?
Right, perfect. And it's closed because it includes 0 and 60, correct?
Yeah.
Okay, so that's part 1. Now, here's part 2. Okay, there's my sense. Yes, v of t is continuous in 0 from the closed interval 0 to 60. Also, I just put that in there. Here's the second part, Noah Jensen. V of 0 is equal to what?
-10.
-10 feet per second. And V of 60 is equal to what?
13.
13 feet per second. That's a lousy 13. Can you see my 13 feet per second okay? Noah?
Yeah.
So I'm going to have an inequality in here. What's going to go in here, I know this is v of 0, correct, Noah?
Yes.
And I know this is v of 60, correct?
Yes.
And I know v of 0 gives me negative 10 because you told me. And v of 60 is equal to 13 because you told me. What needs to be in here?
-2.
Perfect. Absolutely perfect. Okay, which means there exists, here's part 3, exists, what am I looking for? What do I want to have exist? Kaya.
There's like a point in between the two in the interval.
Right, so there exists, notice it says a time t. There exists a t in what interval?
The 0 to 60.
Yes. Where if I plug in that time into that velocity function, it would have to equal what, Kaya?
-2.
-2 feet per second. So that's part 3. And then you end up with two things, Kaya, by what? I put the by, now I got to write 3 letters.
Can I ask a friend?
Oh, I never thought about that. That's a great idea. Is this friend here or you got to call somebody? Who are you going to ask?
Someone in the class? I don't know.
Yeah. You want me to pick them or you want to pick them?
You pick them.
Okay, I'm going to pick Jacob.
Is it IVT?
By IVT, perfect. That's it. Intermediate value theorem. But you know why we do IVT? Because they know you guys are math students and you can't spell. Unless you have spell check. I know some of you can spell. I can't spell. But your IVT is perfectly acceptable. Okay, so what's due by Friday, 8 a.m., and I will do this one tomorrow in class. And so I'll finish up this page tomorrow in class. What's due for you is on the very, very, very back sheet, there are only 2 problems. And you have to do that, and they want a justification or an explanation why this is true. So this is kind of getting ready for that, okay? So that's due by Friday at 8 a.m. Everybody got that? Okie doke? So that's silence. So that must be okay. So that ends our session for today, and we will see gold tomorrow and green in the abyss. And so everybody take care, and we'll see you tomorrow.
Hey, Mr. Kruger.
Yes.
I just wanted to say I won't be there tomorrow or Friday because I had to get tested for the virus because somebody in our English class had it.
Okay, but you're going to be online, right?
Yeah, I'll be online. It's just if you could remember to send the link to me because I don't know if you send it.
Oh, yeah. Okay, can you do me a big favor?
Yeah.
Can you email me that? Because
Yeah,
when
I'll
you
email you.
email me, oh, how about this? This is even better. You've got my phone number, right?
I don't think I hooked up to that properly. I thought I did last year, or like last school year, but I
Okay. So here's my phone number, 320
hold on, actually just let me write it down here. All right.
320-333-9165. Just
So 333 was the second pairing.
Yep.
Okay.
320-333-9165.
All right. Sounds good. Yeah, I can text you that.
Yeah. So I mean, you talk to me, email me, text me. It'll happen. It's
Yeah.
feel really bad about it. I should just remember to do that. But I am
Fine.
so yeah, when I send out a Zoom, I'll have you included during second period. I'll make it happen.
All right. Sounds good. Thank you.
Yep. Good luck to you.
Yeah, thanks.